So I'm going to focus on the older end of the age spectrum and look at the way that possibly engineering can support this group. Clearly, as far as the NHS is concerned, this is a really important group to consider, not just because of the particular needs of that sector, but because they actually consume quite a large proportion of the NHS resources. And what I'd like to start off with, just briefly, is to look at some of the demographics, just to put this into focus. I'm sure you've probably all seen these sort of graphs before, where we're looking at the population in the UK as a function of age. And as you can see, in terms of projections, on the light blue here is where we are roughly today. The dark blue is the projected increase for about 20-25 years' time. And you can see that the bulk of this is going to be in these older age groups. And this is clearly going to have an impact on healthcare provision. If we look at the increase in hospital admissions over the last 10 years, again, as a function of age, or at least looking at different age groups, this is a percentage increase in hospital admissions. There's quite a large increase in hospital admissions over this last 10 years, but the bulk of it is in the older age groups. The actual cost to the NHS, or the usage of the NHS, is somewhat more complicated. And what I've plotted here is a measure of hospital usage in terms of bed days. These are the number of days beds are occupied within hospitals in the UK as a function of age. Over the last 10 years, the light colour is 10 years ago, the dark blue is roughly today. And as you can see, across most of the younger age groups, in fact, hospital usage has gone down because people's stay in hospital has actually decreased over that time. But not so in the older age groups, and particularly the older, even though stays in hospital have gone down, the actual usage has gone up fairly substantially. So the take-home message here really is that in terms of NHS usage, the bulk of that usage is in the older age groups, and the trend is for that to carry on increasing. So in terms of cost, including social services, about 3/4 of social services expenditure is devoted to support of older age groups, and about 2/3 of that in hospital covers the same group of people. So what is the role of engineering? How can we become part of the solution to this growing problem? And of course, a large number of areas where engineers can fit in. I'm going to focus on 3. And these really reflect our own interest in Bath, but they're also all important issues as far as the health system is concerned. Support for fallers, support for people with dementia, and support for people who have survived strokes. Let's look at falling first of all. Falling doesn't seem to be a massive problem. People fall over all the time, but actually in terms of healthcare provision, it is a major issue. They represent the most frequent type of accident for people over 65. About 1/3 of the people in this age group are actually estimated to fall at least once a year. And 5 to 10% of those will sustain a serious injury like a femoral head fracture. The end result of all that is in the order of 650,000 A&E admissions for falls in this age group, 200,000 hospital admissions a year, and an estimated cost of getting on for $1 billion annually. So a major problem as far as the health system is concerned. And there clearly are ways in which engineers can look at possible solutions to try and reduce this burden. It's been known for a long time that one of the predictors of falling can be measured from people's gait. There's a large variation in people's gait, variability in people's gait, if they are prone to falling. And this has been known for some time, that particularly a measure, if you look at stride time or stride length, fallers have a much greater variability in their stride time compared to people who are non-fallers. And it seems to reflect something of the neurology of control of people. They're less stable and more likely to fall because of certain conditions, and that also seems to reflect in terms of their gaits, and the gait becomes much more variable. So in a sense, we've got a nice predictor here in terms of trying trying to screen for people who may be prone to falls before they've had a fall and before they've had some kind of injury. And again, there's a lot of evidence that if fallers are taken through physio programs, various exercises, then their tendency to fall can be reduced quite drastically. Indeed, if you do these sort of measures after physiotherapy, you often find that people who had been categorised as fallers, in fact, their gait becomes much more stable after a period of exercise. So a useful screening technique, but it's not really applicable to primary care type of applications. The sort of equipment you need for doing this in terms of gait labs is quite complicated. We've been doing some work in Bath recently just with simple strap-on accelerometer-based systems strapped on upper leg and lower leg, and with some data processing in here and Bluetooth linked through to a computer. And we find that even with a simple system like this, you can get a good measure of this differentiation between potential fallers and potential non-fallers within about 10 strides. In other words, it's a kind of thing that could be used within, it's a sort of space that most GP practices would have available to them. So as a screening technique, this could enable people to be entered into physio programs and much reduce their tendency to fall with all the concomitant savings. Another issue for fallers is, rather than just predicting the fact that people may have a fall, is to try and provide some sort of protection in the event of a fall taking place. And you're all aware, I'm sure, of the sort of hip protectors that you can get to support people who are prone to fall, to try and stop them getting major injuries like femoral head fractures. But compliance in terms of wearing it is really poor. They look pretty silly. You look a bit like a clown, really, with these things stuck on the side of your hips. Are there other ways in which we can provide protection? And clearly something which wasn't body-worn would be really useful. And there's been a certain amount of work in this area. I mean, clearly floor coverings that were soft and compliant, the kind of things that you have in gyms or around children's playgrounds, would do the trick. But because they're soft and compliant, when you're walking, you're providing the sort of loads that you get from walking, then it's likely to cause more accidents than provide solutions, because it would cause people to fall anyway. What's needed is some kind of material that almost has inverse viscoelastic properties. In other words, when you're applying low loads, as in walking, the stuff is quite solid and firm. But as you provide a much higher load, as would occur in the event of a fall, then it becomes compliant and energy absorbing and resilient. And we've been doing some work on these kind of structures in Bath. Now, I can't show you our one, but this is an example from it's an American patent, actually, which gives you a kind of idea of the sort of thing that can be done. This is a section of a floor covering. It's actually about 1 inch thick, which is one reason why it's not terribly practical, but it has a top membrane and a bottom membrane, and so between the two are a series of rubbery pillars which support the whole structure. And the thing works really well. With low loads, this structure is quite firm. You can walk on it, you wouldn't know you're walking on something that is potentially compliant. But at high loads, the pillars buckle, they become energy absorbent, and locally can absorb that energy from the faller. And okay, this isn't completely an inverse viscoelastic structure, because it's got this threshold above which it will then become compliant and become energy absorbent. But nevertheless, it does the trick in terms of what is required. So there are engineering solutions here for supporting fallers, both in terms of prediction of falls and in terms of supporting them when they fall to prevent injury. I want to move on to an area that's very close to my heart, which is looking at dementia care. I'm sure many of you here have been touched in some ways through people you know with the consequences of dementia. It's a really dreadful condition. Purely from an economic point of view, this is some work that the Alzheimer's Research Trust did recently, looking at the cost of dementia to the UK economy and estimating that the total cost, not just healthcare cost, but the total cost to the UK economy was in the order of £23 billion, dementia, more than cancer and heart disease put together. But other than the economic cost, clearly the personal cost to somebody with dementia and, of course, to their friends, their family, is life-changing. It has a major impact on people's lives. Surely there are ways in which engineering can help here. And one of the things that people with dementia want more than anything else is to be able to stay in an environment that's familiar to them in their own home, rather than go into hospital, rather than go into care. And we've been doing quite a bit of work on looking at autonomous smart homes, which have the ability to maintain that independence for somebody who has dementia. And all these homes do is have a series of sensors that can monitor people's behaviour, monitor the way they interact with their environment, and then have a series of support devices like automatic cookers, which will turn off in the event of somebody doing something a bit silly with a cooker. And linking the sensors and the support devices be some kind of communication network which does what it says. It now enables everything to communicate with everything else, but it has some kind of inbuilt intelligence that can use the information that the sensors are providing to make judgments about how best to support that person. And only in the event of emergencies does it need to call for help from outside. Now, this seems like reasonably sophisticated technology, and okay, it is to a certain extent. And you might wonder how on earth somebody with dementia could control this kind of thing if they have a job, even making a phone call or dealing with controlling the TV. But what this technology can do is kind of emulate what a living carer would do. It can look over somebody's shoulder and monitor the things that they're doing within that environment and to provide interventions that can help maintain their independence and maintain their safety. Let's look how that might work. And this is a cutaway of a toilet area showing the communication system in place, and a series of sensors. Sensors in the tap, so you know that taps are being used. Sensors which can detect movement, PIR sensors, passive infrared sensors that will tell you whether you're in there or not. We also have reminder units, which I'll talk about in a moment, and a level sensor in the bath. So how would we deal with a situation where somebody might be running a bath and forget about it and causing a flood? Well, if the person was in that room, and was running the bath, then the house would know through the PIR sensor the person is in the bathroom and also that they're running a bath because of the tap sensors. If the person then went out of the bathroom, we can provide a reminder. We use voice reminders a lot, find them very effective, to say, don't forget, Mum, you're running a bath. If the users didn't respond, we can then wait till the bath is full, turn the taps off without taking control away. We don't shut the water supply down. We can turn the taps off and then give some kind of reassurance to the person living there. Your bath is ready, Mum. I've turned the taps off. So it's kind of copying the strategies that a personal carer would employ in supporting that person and using technology to emulate those strategies. Yeah, I will briefly talk about this. I'm running slightly short of time, but as an engineer, it's always nice to talk about bits of equipment. The tap that I mentioned there is a crucial part of that design because it'd be so easy just to have a solenoid valve, shut the water supply down, you save the day, but the person comes back to the bathroom, they can't run a bath anymore, everything's been shut down. When I put a bit of hot water in, nothing happens. So what this tap does is it doesn't actually control the water directly. It has, the tap itself is connected to a shaft right down through all this lot. And when you turn the tap, there's an encoder down here. You know how far you've turned the tap. You can use an electronic valve to let flow through at the appropriate rate. If the house has to shut things down, then it can turn off the flow valve. It can put a brake, electromagnetic brake on this shaft. So the tap feels like it's off. It hasn't moved, but as far as the user is concerned, that's now been turned off. And it can reset the encoder back to the start again so that it can still operate. So quite a neat little design. The lad who did it, he's a good designer. I'm glad somebody mentioned design. It is important, obviously, in this whole area. But it wouldn't have come about just by somebody thinking, I can think up of a good idea for tap. It came about because they worked through how people behave in that environment, what carers have said, this is how I would deal with that situation, and trying to use engineering to reflect the strategies that people had adopted. So this kind of technology can support in many ways, with lighting control, supporting the toilet, guiding people to the toilet, prompts, time to take medication, etc. Appliance usage, monitoring use of telly, so if you know they're enjoying themselves or not. Supporting the bathroom in the way I've been talking. Movement sensing, so you get some idea of whether people are restless. Or supporting the kitchen, you can turn the cooker off automatically if behaviour warrants that. Nighttime support, you can tell if somebody's restless, if they're getting in and out of bed all night. Wandering support, if somebody tends to go out at night, then you can try and dissuade them. And only in the event of certain emergencies, and we use, if somebody is prone to wandering, we've tried to discourage them from going out, but they still do, then clearly you've got to get some help. We also are concerned about restlessness and anxiety at night. If that continues, then again, we will call for help. And support in the kitchen, if at any time the cooker has to turn off automatically, then some help will be called. And it works really well. I'm just briefly going to look at a longitudinal trial that was run. We've run these in London and in Bristol. And just to look at this one personal case, just to highlight the kind of things that this technology can do to somebody's life. This particular chap had fairly well-developed dementia. He had a continence problem. He wet himself an awful lot. Very confused, very tired, and he was prone to wandering. We put all the sensors in before we turned any of the support technology on, just to get some idea of what his behaviour was like as a baseline for looking at the impact of the technology. And it was clear straight away that he was very restless at night. This is from midnight through to 2 o'clock, in and out of bed, wandering around his apartment. It appeared he seemed to be trying to find the toilet. And when we looked at sleep, this is hours of sleep over the month before the turn technology on, he clearly wasn't getting much sleep at all, in and out of bed all the time. So what we did in setting this system up was to, if he got out of bed at night, we could detect that with bed occupancy sensors, and we'd fade the bedroom light on. We'd also turn the toilet light on and give him a voice message. It was his daughter's voice. I've turned the toilet light on for you, Dad, just to highlight the fact that toileting is an issue, and also to highlight the fact this is where the toilet is, to help him locate it. If he finished in the toilet, was wandering around for a while, we could detect that, initially do nothing, but if it carried on for a while, then again we can use his daughter's voice to say, come on, Dad, you should go back to bed now. If he didn't, and that carried on for a while, then, if he did go back to bed, didn't turn the light off, then we can wait a while and then fade the light down. But if he still carried on, then as I said, if people are shown to be restless at night, we will make some sort of intervention. And the impact of this was quite profound. I mean, sleep certainly improved quite a lot. I mean, it was still quite poor, but this was averaging much closer to 6 hours a night. But he was also dry. From that point on until the end of the period he was in that care home, he was dry. And that obviously had a major impact on his quality of life and for people around him. Okay, I'm now going to look at just one final issue, looking at support for stroke survivors. Stroke is a major issue, clearly, 150,000 cases per year in the UK, and most of these tend to be in the older age group. And it's the third most common cause of death after cancer and heart disease. And in terms of hospital usage, about a quarter of long-term beds are taken up for people with stroke. Now, a lot of the potential interventions in terms of engineering are really in terms of rehabilitation and ways of encouraging people back to as much good usage of their neuromuscular system as is possible following the stroke. One area that is of much interest is trying to look at a kind of emulation of physiotherapist intervention where it's known, and the NICE guidelines underline the fact that repetition of movements is a useful way, an important way of trying to encourage recovery of neuromuscular system following a stroke. But that's pretty intensive in terms of physio time. And robotic devices like this one here, where the Universities of Reading and Newcastle were involved in this country, can do that. They can take patients through exercises, they can encourage patients to carry out exercises and provide force feedback, haptic feedback. So it very much is doing the kind of things that a physio would do. Also work going on in Bath is looking at the fact that following the acute phase of stroke, and people have gone home and they're encouraged to carry out exercises, to do these repetitive actions to try and aid their recovery. Compliance is poor. It's boring to carry out long-term exercises. You don't really see what it's doing for you particularly. And this program, the Smart One program, which was run in Bath, used, again, accelerometer-based sensors mounted on the upper arm. This work was aimed at upper limb rehabilitation, with the sensors linked through to a data processing unit that then was used to control images on the screen. And what the user saw was a mannequin where they could see the motion that they were being encouraged to carry out through one part of the mannequin, and then they were shown what they had actually achieved through the sensors. And after a period of time, you can't really see that, but this is a graph of their progression, the way that their movements have improved over time. So they're given feedback here to encourage the action, and also feedback to show that they are actually improving. And this whole system can have a web link through to the physio in hospital, so they can keep an eye on how the patient's doing. This sort of home management of conditions is clearly going to be an area that's going to develop a lot. And the SMART program that's being run, SMART 2 now, is looking at developing these techniques for supporting people with chronic pain and congestive heart failure as well, to encourage people to go through various activities and using CBT techniques to help them deal with issues that crop up. They're going to be a big developing area, I feel. Okay, I'm running out of time, and I just briefly want to say something to my engineering colleagues, because this whole area has flowered over the last 10, 20 years. We all know that in looking at the way technology can support older people. And a key factor which we've always underlined, and which indeed the research councils have underlined in some of their programs, is the importance of user engagement. And I'm slightly concerned that this often in a lot of people's programs as being a few focus groups or a few questionnaires, and it really does have to be far more than that. The users of this equipment are the experts. They know what it's like to have a stroke. They know what it's like to be living with dementia. And they have to be engaged with in a fairly intimate kind of way to make sure that the development programs that we're engaged with are actually taking on board that perspective. Because you can't do it. As a designer, you can't sit back and say, I know what would be good for somebody with dementia. You've got to have them on board and look at their behaviour, look at how they interact with the things that you're developing, take as much measurement and observation as you can to make sure it's effective. Just a brief example. This is a device that we explored some time ago to try and prevent wandering for people with dementia. And we would advise, it's a voice, it generates a message to say, night time, I shouldn't go outside. Got a sensor on here so it can detect somebody being near the door. And it can provide that discouragement from going outside. We were advised by healthcare professionals working with people with dementia that actually voices coming out of the ether might not be a good idea. People would get a bit freaked out by that. And also that if it was a voice that was recognised, people might think, no, my daughter's telling me something, she must be in the house somewhere. Logical advice, it made a lot of sense. So in the early days, we made voices come out of the radio, out of the telly, a bit tricky, but you can do it. But we quickly found that actually that wasn't the case at all, that people were quite happy with voices coming out of little boxes, as long as they could see where it's coming from. It was part of their common experience that that's what happens, with record players or other devices. And initially, we used an anonymous voice. It wasn't a recognisable voice. And we ran a trial with these. We had 10 of these out, all with patients with a living carer, set this up with our research OT's voice, telling them not to go outside. And it was okay, it worked quite well, but people habituated to the message. So we rang around all the living carers to say, because these things had a recording facility on them, can you say the same thing yourself? No, just use different words, just so it's a new message. And lo and behold, it was far more effective using that person's voice. And we've gone on to pursue that further with our smart home work. And there's no doubt about it that a voice that somebody trusts is much more likely to, the advice is much more likely to be followed than if it is just an unknown voice. And people don't think that that person's in the house. They quite accept that, voices can be remote from the person, as with a telephone, etc. So the advice from the care professionals was fine. It was quite logical, quite right. But it was actually wrong. And the only way we found out was through engagement with people to see how they actually behaved, what actually was the outcome of interacting with this new technology. And that needs to be built into the design and development program in order to tease out these sort of issues. So enough of the sermon. I'm going to finish there now. Clearly, there is a big need in terms of supporting future development of the NHS in looking at the issues that are faced by our ageing population. But there's no doubt about it. There's an awful lot of potential for engineers to look at novel ways of providing support and linking through to enabling people's lives to be improved. We must engage with them to develop it, but if that engagement takes place, then this sort of equipment can be really effective and can have a major impact on the support our society provides in terms of healthcare. Thank you very much.
Thanks so much for that, Roger. Any questions to Roger? Anyone? While you're thinking, did I see a hand? No. While you're thinking, it does strike me that very often that old people are not always at the head of the queue when it comes to getting resources of any kind. And I wonder what the position is when it comes to resources to research in this kind of field. I mean, do you find you're struggling against more favoured groups, or is it not a problem?
It is a bit of a struggle to get research money. There have been a number of initiatives through the research councils, and the EPSRC had an excellent programme, the Equal programme, which they ran a few years ago, which was focused just on this age group. They also made it mandatory that any research group had to engage with user groups in order to have a chance of getting any funding. There is money there. It's not a glamorous area of research, but again, the EPSRC have run programs to try and encourage younger researchers to apply their skills to working in this area, and that's been pretty successful, I think. I don't think it's any more difficult to get funding to work in this area than other areas of medical engineering.
And that one other thing there that occurs to me too, that business about checking when the device was in place, whether the voice was really effective, that relates back to what someone was saying earlier on about post-marketing surveillance of how these devices work. Because you could really easily say, well, look, the box is doing what it's supposed to, it delivers the message, fine, we're home and dry. It's only when you actually go back and see what it's like in practice, you realise that maybe there's a better way of doing that as well.
Absolutely, and that underlines my point that process needs to be built into the design and development process. If you leave it to the end, if you develop up a project and say, right, now we're going to test it out with all the people and see how they behave, then it becomes very difficult to start changing tack or redeveloping your product. You may have tooled up to get to that sort of point. So it's quite important that engagement with the user, the evaluation of actually how people really do behave with that device is taking place during the development activities before it's got to a point where commercial people are saying, okay, we're going to market this thing now.
Can I?
Yes.
I'd just like to make an observation, really. It's not entirely your patch, really. I think that the business about older people falling, when they're in the home that they've had for a long time, could be improved if somebody went in and did what they do after they come out of hospital. They put the handrails in before they've had the fall, and things like the kitchen cupboards, they were all right when they were 40 and they could stretch up, but actually now they're 75, they can't reach the top shelf, but they're still using it, and it now becomes a stress to get up there or get down to the light fitting the plug on the floor. And it just seems to me that bit of money that's used when they've come out of hospital to make the house more usable in this post-hospital stage, if it was applied before, you might have less falls.
I think that's absolutely right. Whose home do you go around and check to see if which is why I feel having some means of screening people to look at people who are at risk, other than just ask them, now, have you fallen a little bit lately? To actually have some means of saying, actually, this person really is at risk. And then the sort of processes you're talking about, which, an OT will go around and assess somebody's house to see what issues are cropping up in terms of the usage of their kitchen, whether there's mats on the floor that they're going to trip on, all those sort of things that are really important. And as you say, will tend to take place now once somebody's had a fall. If we had a good technique that said, actually, this person, a good, cheap, easy-to-run technique that said, this person is at risk, let's go and do the sort of things that you suggest, very sensible.
Roger, thank you very much indeed for that.